Okay, generally, the formula for solving big word problems like we have in 1.7, which is that worksheet we've been working on, is you start by drawing a picture. I want to give you a little problem right now. Let's say that you were making a box. You've got a single piece of cardboard. And did you know that all boxes, I shouldn't say all, that's a big word, almost all the boxes that get mailed to your house, the cardboard boxes, or ones you pick up, you know, a VCR at Best Buy, or VCR, I'm dating myself, a DVD player at Best Buy or whatever. The boxes that you buy are a single piece of cardboard that has been cut creatively and then folded up and then glued. So it's not like multiple pieces of cardboard that are glued together. It's a single piece of cardboard that is cut out in a certain way and then folded up just right. Okay? So you're going to be taking and making a box for this next little problem. So start with a rectangle. And let's say our raw material was 60 inches long by 30 inches long. And for just to make your life easier, I wouldn't not include the units because, okay, so it's 60 by 30, and I'm going to try to make a box out of this. Well, to have any chance of making this actually look like a box, I need to make some cuts. And to keep it simple, this could get really complicated, but we'll keep it simple. We're going to cut squares out of the corners of this box, like this. By the way, this is almost exactly like one of the problems on your worksheet that you're going to have assigned later. So pay attention, you'll learn this process, and it'll help. Now, actually, if you did this with pencil, you can actually erase these. That would be smart, because now it'll make it a lot easier for you to see what it's going to look like when I actually fold the corners up. And let me see if you can understand what I mean. If I make little dotted lines here, can you imagine that I could fold on those dotted lines, and then this would fold up to become a box? It's a super simple one, but it would make a box. All right, now, how long was that side that I cut out? I never told you, did I? What should you put? Oh, hold on. I need this answer first. Okay, raise your hand and I'll get to you. Okay, what do I put for the thing I don't know? X. And if this is X, then so is this, because it was a square, right? And so is this, and so is this, and so is this, and this, and this, and this. Those are all X's. Okay, so far we have completed the first two steps of my multi-part process you should always follow. First, draw a picture. Second, label the picture. I have labeled my picture with my 60-inch starting size. And then once I fold it up, do you get it's not going to be 60 anymore? Okay, we'll have to factor that in a minute. This is 30 inches that way. Okay, now so you wanted to stop. Question?
Yeah.
You are correct. This does not have a top. You could fold it in a more complicated way, so it would. If you just think about it, if I left this be a lot longer, do you get how it would have a top I could fold over? Okay, and then you could even make it more complicated, make a little tab to fit in, you know, so that when you're done, you could fold it over and stick the tab in. See, we could make this much more complicated and more realistic, but it'd be a bit of a pain for you to actually solve. Okay, so there's my picture part. What's the next step in solving a complicated math problem? It's make me a pure formula. Since this is about a box, the formula involved would be volume. I'm going to pause for a second. Okay, so here's the pure form of the formula. Volume equals length times width times height. Now, this is really important part. All the problems that we give you in this unit, we tell you what we want the answer in terms of. So in this case, let's say that we want the answer in terms of the height. Then that means it's not supposed to have this L and this W in it. That would mean my answer was in terms of the height. Well, how do I get the L and the W out of there? You go like this. Instead of the L, I put an empty spot. Instead of the W, I put an empty spot, and then the H is still here. Do you get that this X that I've been using the whole time is actually the height? Imagine for a second that we folded the box up. You get that the x is actually the height of the box? All right. So these could all, instead of little x's, they could all be little h's. Don't have to go change them all, but do you get the idea that those are really the heights of the box? All right. Now, I'm going to just make my life a little easier because I drew my whole box with x's. I'm going to make the height x instead of making it an h. I'm going to make it an x. Then, all I have left is I got to get this length and this width. Where are they going to come from? They're going to come from my picture. That's what tells me this key point. Because I think all of you would be able to write down the pure formula because it tells you in the problem. It's volume, it's perimeter, it's whatever. You'll be able to figure out the formula. Hopefully you know some of those formulas. Every one of the formulas I do in class, I would write down, and if you didn't know that one, I would make yourself a little list. Like, I think most of you knew this volume formula, but if some of you don't, well, I can guarantee you there's going to be volume questions that you're going to have to answer on the test. If I do it in class, you got to know that kind. All right, so anyway, length times width times height. Back to this. I need a length. I need something to put in here for length. Just look at the length here. Length is the longer one. It used to be 60, but once I fold it up, this requires a little bit of thinking. Do you get that it's less than 60? It's 60 minus, you're close. 60 minus 2x's, right? Because we have to take one off this end and one off of that end. 60 minus 2x. And do you get how we're getting close to having it only have x's in the answer? Now I just got to do one more. That's the width. That's this. It's not 30 anymore. It's 30 minus 2x. Now I have my volume in terms of x, which we all know is actually the height. So if they had said volume in terms of the height, I've done it. All right, let's get to that question again, except I want you to try it all by yourself. Let's say that I said that you had a different fresh piece of cardboard. This would actually be a rectangle though. And it's 18 by 14, and they want you to cut the corner out being a square and everything, same kind of deal. Okay, and this time they're going to tell you that the volume needs to be 48 cubic inches or whatever. Write me a formula that you could use to solve this problem. And it needs to be in terms of only the height, or you could say x. Just like one just did 2 seconds ago. It's just that I gave you the volume this time. Pause for a second while you work on that math. All right, so I gave you a little time there to work, and hopefully you figured out that it's volume equals length times width times height, and then you figured out that the length is really not 18 anymore. You take away a couple of x's, so it's 18 minus 2x. And the width you should have figured out isn't 14 anymore. It's 14, take away 2 x's. And then the height is x. There we go. Except, what did I leave out? How many of you are smarter than me and put the 48 right there? All right, way to go. That's what I was looking for. And then, by the way, at the very end, on the test, there'll be some where you can use a calculator and some where you can't. On this kind of a problem, you'd be able to use the calculator, because then what would you do? The calculator is especially good at doing something with a G. Graphing. You would graph that thing, and you would graph both sides and see where they cross. This is a line, y equals 48, that goes like right here at 48. And the other one is, it's got 3 x's, so it's curvy, so it might be like this. And it might have 2 different places that it crosses. And only one of them is actually possible because of the size of our box. So we'll get much more complicated with this problem, but for right now, the basics is that we wrote this answer in terms of x. All right, here's another formula. Let's get that in terms of stuff figured out. What if we had E equals mc squared? Do you guys know what the E is in E equals mc squared? Energy. Good. How about the M? Mass. And how about c squared? Speed of light squared. Good. And it's also known as the acceleration constant. Thank you. Anyway, I may be saying some of this wrong. I am not a physicist, but I know that this formula is one that you all know. And if I asked you to solve this formula for m, I think most of you would know what that means. Get the m alone. So divide by c squared, divide by c squared. Now that's solved for m. All we're asking you to do is stuff like that, except we want your answer to only have, for instance, energy in it. And right now, this has two variables. That's why your answers for this whole packet, it says at the bottom, write an equation for y in terms of x, or write an equation for the height in terms of the radius. So when they're saying in terms of, that's in the answer. In terms of, and this is the thing you're solving for. All right, so let's give you another one. Here's the perimeter. Let's say I said to solve for W. Just solve for W to start with. I'm hoping you're subtracting 2L, because you should have noticed that the way it was attached to the W was with a plus, so you subtract. So then it's P minus 2L equals 2W, and then to get the W completely alone, I divide by 2, and W is equal to that. P minus 2L over 2. Raise your hand if you had that one right. Good. We solved for W, but now we've added an extra little thing in. And we would say, not just solve for W, we would have said, solve for W in terms of L. So all of my answers good except for what little part? The P. So I'd have to take that P out of there, put an empty spot, and figure out what I could put in instead of the P. And that's usually some other part of the problem, where they'll have, like, you know, some other little formula that has a P and an L, and let's say it's like L is equal to 4 P's or something. And you got to say, okay, well, I had a P here, but it wasn't going to be okay. I needed it to only have L's. So then I solved this one for P. Divide by 4, divide by 4. P is equal to L over 4. And then that means I'd put L over 4 right here. See how my answer only has L's now? All right, that's the point is, for a problem like, for instance, let's do one together. Let's do number 25. Everybody grab your packet. Your assignment was 1 through 24 before, and I've got some of those. Yes, question? Yes, if you haven't got one, come on up. I will give you a chance to get some more help on some of those last few problems that, like, I know 21, 22, those were kind of challenging, but for right now, I'd just like to start a new one with you. Number 25. Your assignment for today is problems 24 through 34, and I think I already assigned 24, but I'm going to help you with it later. Okay, so it's just up through 34 in the packet. Number 25. 25 says the area of a circle in terms of the circumference. What? The area of a circle in terms of the circumference. All right, so we should start with a picture. Isn't it a circle, right? So always start with a picture and then label it. That phone goes on my desk. All right. What's this little thing doing? Oh, that can go on my desk too. All right. So this is the radius. That's enough for labeling this thing, I think. Now, remember, after we're done with the picture, we all need a pure formula. What's the formula I should use for this one? A equals pi r squared. And that's the area. Are we done? No, it's supposed to be area in terms of the circumference. So what little part of this is not okay? The area is solved. It's in terms of r, though. I didn't want the r. I'm going to leave an empty spot there where that r was. See how that was the only problem? Now, if I could just put in a c, that'd be great. But is r exactly equal to c? No, so I can't just slap a c here. But I want something with a c in there. So how can I do that? I go off to the side here and I think of some other formula I know about circles that's related to the radius and the circumference. And can anybody pull up a circumference formula from the back of your brain? Yes, very good. And remember, I said any formula I do on the board, you better know. If you haven't got this one memorized, make yourself a little list of formulas you should memorize. All right. I know all of you know pi r squared, at least I think you do. But this one might be more of a stretch for some of you. Okay, remember how this is the r that I want to replace with something? So I got to get the r alone first. Then I can replace just this r with what it's equal to. So I got to solve for r. So everybody solve for r. And r's alone. And now can I put that over in here? Go ahead and try and see what happens. C over 2 pi. Now I'm going to go back to the original problem, and it says the area of a circle in terms of the circumference. Do I have the area of the circle? Yes. Is it in terms of only the circumference? Yes, it is, because that pi doesn't count, because that pi is a number. It's 3.14. So that is only in terms of C. That C is the only variable in there. Pi is not a variable. Pi is a number. So good. I'm done. That's it. That's the area in terms of C. All right. Next. I know some of you struggled with some of the previous ones. Look back at problems 21, 22, 23, 24. Are there any of those that you want to specifically ask? And no, don't say all of them. I can do like one of them. Are there any nominations for, I was really stuck on this one? Yes. Number 20? Is that what you're asking for? Yeah. Okay, number 20. Everybody look at number 20, and unless you already have completely nailed that one, and if you have, then go ahead and work on a different one. Number 20, the difference between 9 times the first number, oh, wait a minute, 9 times the first number, and I'm always going to call the first number x. And when they give me a second number, I'm going to call it y. When they give me a third number, I'm going to call it z. X, y, and z are really classic variables for teachers to use. The difference between 9 times the first number and 3 times the second number, here's my 3 times the second number. I usually use y for that. And what did they say about those two? Difference. Subtract. Is 21. Ooh, equals 21. Yay, I have written my first equation. Now they're going to give me a second equation. The sum, ooh, that means plus, of twice the first number, what was that then? 2x, and 5 times the third number, 5 times, what's the third number going to be? Z, is 95. Cool. I would expect you to be able to write those. That shouldn't have been impossible. Write an expression for the product of all 3 numbers. All right, this part gets confusing. The product of all 3 numbers, well, all 3 numbers are what? X and Y and Z. And what's product mean? Multiply them. So I just need to go X times Y times Z. And is that the answer? No, because it says in terms of only one variable. Let's pick that to be X. We want this to be in terms of X. This would be right if they all were just X's. So we're going to write it with the X and then empty spots for these other 2. Okay, this Y, I have to figure out something to put in for Y. Can I find Y somewhere else? Right here. Solve that for Y and you'll know what to put here. And then this Z, I got to solve for something else. I got to get it in terms of X. So I'm going to get this Z from here. This is going to be where I find Z. Solve for Z right there and get it down to like Z is equal to 95 minus 2X or whatever it is, but it's not that. And once you find that, put it here. And then you'll have your answer, and it'll only have X's in it. So it'll be in terms of X. Yes? I understand that it takes some it takes some space. And you're right, we really didn't leave you enough space to solve all these. So you're certainly welcome to use a piece of scratch paper, and that would be just fine. It's not going to take that much room, really. I just need to solve two equations. I need to solve the black one I circled and the one that I circled in green. Okay. But you're right. Point noted. Should have more space next time. Soon this will be an iPad-only class, and then it won't matter how much paper it takes, and then we can like put one problem on each page, and you can just swipe to the next page, and you'll have plenty of room. But I know you guys won't be in the class anymore. Okay, moving on. Any other nominations for help on those harder ones on last night's assignment? 19, 20, 21, 22. Anybody want more on those? All right, you can always ask me. Oh, 23. All right. The area of a triangle. Ooh, I know a formula for that, but first I'm going to draw a picture. A triangle whose base is twice the height. Okay. Base is twice the height. Notice I gave it a really big base. And if the height is h, this is twice the height, 2h. See, I drew a picture and I labeled it. Step 1 and 2. Next thing, write a pure formula. What should I be using here? Area of a triangle. What's the formula? And don't forget the A equals 1/2 base times height. And why isn't that an okay answer? Because they want it in terms of height. They only want the height. So I'm going to rewrite this puppy with only an h in it. So I got to put an empty spot where the b was, and then an h. And do you get now that I have to replace that b? So where am I going to get that from? Ah, the base is right here. The base is 2 h's. Here we go. See how drawing that picture helped me? Okay, let's move on to some more of the new stuff. Everybody flip it back over and take a look at 25 through 30 on that page. Has anybody worked ahead and gotten stuck, want to nominate a problem? Maybe you haven't worked ahead enough to know. How about we just go with 26 then? The perimeter of a rectangle is 12. This one is tricky. Perimeter means add up all the sides, right? Okay. And I know that all the sides add up to 12. So how do I say that on the picture? I don't know. These are all going to add up to 12, so I can maybe I'll make a thing like this that says this all adds up to 12. Okay, there, I've drawn and labeled my picture as best I can. Can you stay with me, please? I'm almost done. Number 26 we're on. Find the area of the rectangle in terms of the width. This is the part where I have to write a pure formula. Area equals, what's the area of a rectangle again? Length times width is what we usually use, but base times height would have worked fine. And it only wants width in the answer. That's another good reason to use length times width, because it's already got a W. So get how everything's good except this L. So I got to figure out what to put for L. And then I'll have it. This is tricky. If this is the length, this part right here is the length, do you get that the total is 12 for all 4 sides added up? So then, to just get L, it's related to the W, right? The width. But to get one of those L's, isn't that going to be 12 total for the whole thing minus the 2 L's, or the 2 W's? It's close to that. I'm going to say that again. This is kind of like the thing we did yesterday. Remember yesterday when we said there was 2 numbers that add up to 20? And if they both add up to 20, then one of them could be x and one of them could be what? Do you remember? 20 minus x. Good. Those would add up to 20. I could call them x and 20 minus x. Remember that? Okay, back to this. This is a rectangle where all the sides add up to 12. So do you get that this side could kind of be 12 minus something? Okay, what would we need to subtract? 2 W's, 12 minus 2 W's, and then that other side. But since this side is exactly the same as the other side, do you get that the two black sides here total would be 12 minus 2W? So one black side would be 12 minus 2W divided by 2. This side right here would be 12 minus 2 W's, but you also have to take into account that that only gets us part way because then we have two sides left, and so I have to divide it by 2. That was a tough one. 12 minus 2W over 2.
I tried to figure it out on my own. Make a perimeter that finds, to make a
Go ahead.
perimeter that finds 12.
Okay, okay. And the problem is that there's so many different combinations that could work. Like, couldn't you make it 3, 3, 3, and 3? That would add up to 12, right? Or couldn't you make it, 4, 4 is 8, 9, 10, 11, 12, 4, 4, 2, 2, yeah? But we don't know what it is. It might be decimals. What if it's like 4.3 and 4.3 and then 1 point something and 1 point something? There's too many different combos to try to figure it out that way. So we have to use pure math to figure this out, not just guess and check. Okay, let's move on. Question? Okay. Let's go on to 29, I think is a good one. I know things that are important. And there's circles. Circles are different than the other shapes since we use them a lot. All right, a piece of wire x pi inches long is bent into a circle. Okay, so I've got a circle. And the total distance, this is once again known as the circumference on a circle, or the perimeter. The distance all the way around this thing is x pi. I've drawn a picture and I've labeled it. What's the next step in success here? Pure formula. What's a pure, what are we doing on this circle? You know its area? Does it say in the problem that we want the area? Okay, well now we should do the area formula. What's the area of the circle? Okay, so area pi r squared. Why isn't that a good enough answer? Because it doesn't want the area in terms of r, it wants it in terms of x. So I have to rewrite my formula, pi empty spot squared, and now instead of that r, I got to put in something. I just can't just put in x. I got to figure out what to put in. That's the only hard part about this problem. So far, all I've done is write down a formula. So I got to figure out what to put right here. So I need to figure out what r is, really, then, right? I got to get r equals. So I got to get some formula, other formula that's got an r in it. The circumference one. What's that one I told you to remember from the last problem? Circumference equals what? 2 pi r. And we happen to know the circumference in this problem. Because remember how they said the circle was made out of a wire that was wrapped around, and so therefore the circumference is x pi. X pi. And now, what do we need to get alone? We need to get r alone. See, we were trying to get r. We're going to solve it and drop it in there. So r needs to get alone, so we divide by 2 pi. Divide by 2 pi. And by the way, these pi's cancel too. You see that? There's one on the top, one on the bottom. Yeah. Yep. R equals x over 2. So what do I put right here? X over 2. All right, is my area done? It asked me for area in terms of x. Is there only x in my answer? Yes, there is, because pi doesn't count. That's just a number. All right. Cool, we did it. How do we do it again? We started with a picture. We labeled the picture. Then we got a pure formula. And then we figured out what part of that formula we had to replace. We have left an empty spot. Remember, we left an empty spot right here because we didn't want an R in it. We wanted an X in it. And then we had to come up with some other formula that would use to solve and get R alone and then drop it in there. And that came out to X over 2. And that's how we got our answer.
So we're supposed to memorize
Every single formula in the world? Is that what I said?
every single formula that's relative to shapes, pretty much.
Every single formula that's relative to shapes is still a really big number of formulas. What I said is you should memorize every formula that I used on the board. Do you remember that? So every one I've used, you should memorize. So that's why it's good to take notes. And also, as you're going through it, if I didn't do a formula that you don't know, I'd make myself a little list of those. Like if you didn't know C equals 2 pi r, but that was one that you didn't have memorized, you definitely should write that down. 2 pi r. Okay. And that's all I've got for you for today.